This is mathheals.com, where you can find more links to math and computer science YouTube videos. Let's take a look at tangent planes and normal lines. And the first thing we'll look at is how to get a unit normal vector to the surface at a given point. And these are our steps. First step is to find del f. Second step is to plug your point in. Third step is to find the magnitude of del f after you plug your point in, and then to find the unit normal vector. So let's take a look at these steps in more detail. (5x minus 2y plus 3z is equal to 0. And it's at the point 2, 5, and 0. It says find a unit normal vector to the surface at the given point. Now these are our steps. First step is to find del f. Now specifically the f you see on the right side here, partial with respect to x, partial with respect to y, and partial with respect to z, means you have everything over one side of the equals. So you should have a 0 on one side, and then this is going to represent your f. So finding our del f of x, y, z is going to equal to the partial with respect to x, I, plus the partial with respect to y, j, plus the partial with respect to z, k. So again, if I'm taking partial with respect to x, then the y and z are considered like constants, numbers. So the negative 2y plus 3z drops away, and derivative of 5x gives us 5. So this is 5i plus partial with respect to y. The x and the z term will drop away, and we're left with negative 2y. Derivative of negative 2y is negative 2. So negative 2j. And then the partial with respect to z is 3. So we'll have 3k. So we've got 5i minus 2j plus 3k. And step 2, plug in your given point. Well, del f of 2, 5, 0. Since there is no x, y, and z here, there's nothing to plug in because this would be our x, this would be our y, and this would be our z. So it's just the same. It's 5i minus 2j plus 3k. Then the next step says is to find the magnitude of that. So the magnitude of that will give us the square root of 5 squared plus negative 2 squared plus 3 squared, which gives us 25 plus 4 plus 9, which gives us 38. It's 29, yeah, 38. Then our unit normal vector is going to equal to del f over the magnitude of del f. And that's after we plug the point in. Well, del f from step 2 was 5i minus 2j plus 3k over the magnitude, which was a square root of 38. So that's going to give us 5 square root of 38i minus 2 over square root of 38j plus 3 over square root of 38k. which is going to give us Multiply top and bottom by square root of 38. So we got 5 square root of 38 over 38i minus 2 square root of 38 over 38j plus 3 square root of 38 over 38k, which gives us 5 square root of 38 over 38i minus 2 and 38, both divisible by 2, so we got square root of 38 over 19j plus 3 square root of 38 over 38k. And that's our answer. Now let me see if I can graph this. Let's see. Okay, so I do window, 3 dimensions, and I need equation. I'll do explicit, which means I need to have it solve for y, or solve for z. Sorry. So if I take the see, this becomes 3z. Take the 5x minus 2y to the right side, and becomes a negative 5x plus 2y, and then multiply everything by 1/3, and you get z is equal to negative 5/3 x plus 2/3 y. So over here I'm putting in negative 5 divided by 3x plus 2/3 y. So 2/3 y. And click OK there. And view axis. Let me put a point at where we're looking. We're looking at 250. So do an equation, point, Cartesian. I'll put in 250, and I'll choose solid. Now I'll make it 4 to make it a little bit bigger. And click OK. Obviously, I don't have it going through the... Yeah, no, that's right. Oh, doesn't go far enough. I was going to say, it's not on a plane. That isn't right. Choose this graph here, do edit, and choose negative 5, 5, negative 5, and 5 for my x low, high, and a y low, y, and so forth. Okay. And, oh, that's still not quite far enough. I guess I should have looked at what my point was. And choose negative 7, 7, negative 7, 7. There we go. And if I get that selected, there we go. Okay, so now I see my point. And our vector n is equal to this. So starting at this point, I'm going to draw a line segment. I'm going to do an equation, segment, and for my beginning, I'm going to put in 250. It's going to come from 250, and then where it's going to end up at is 2 plus this value. I'm going to put in 5 over square root of 38. So I got 2 plus 5 divided by square root of 38. And this one will be 5 plus 5 minus 2 divided by square root of 38. And this one will be 0 plus 3 divided by square root of 38. Okay, now assuming I did everything right there, let's do our arrow at P2 and arrow size 10, that's fine. Click OK. And 2 to 2. Well, let me put that in my calculator. See, 2 plus 5 divided by square root of 38. To 2.8, 2.81, and 5 minus 2 divided by square root of 38, 4.68, 4.68. And then this one would be 0.3 divided by square root of 38. 0.49. 0.49. And let me choose 14 here for that. Arrow size, pen width, might be okay. Let's click OK. It's hard to see. Wonder how I zoom in. Page, there we go. Now you see how it's pointing, where it's pointing at? I know it's kind of hard to see the rotate. Now you should be able to see that. That's what that gives us, and it's specifically at that point. Now for a plane, it's kind of, well, that's kind of obvious. Where these are used at, it hit me in class because we deal with normals in a package called Blender. It's an animation package. Let me see if I can go to it. And go to Features and Gallery, and go to Gallery. With Blender, you can create models, and with models, you want to generate hair. And the normals we use to tell what direction the hair is going. And so you'll pick part of your mesh, part of your the head, for example, and then you'll generate hair based upon what you've selected, and it's based upon the normals. So if the normals are pointed the other direction, then the hair grows inside the skull. So you have to flip them, and then that's how you generate hair. Now it's no more than just hair; it's also wind and other items like that. So it has a if you've worked with any of those packages, or will be working with any of those packages, that's one example of where you use these at. It's kind of cool when that finally made the connection between what I'd done with Blender and what you can do, what you're finding here. Okay. Do I have room? Let me save that. What are we dealing with here? Tangent planes and normal lines. Calc 3. Tangent planes and normal lines. Page. Lines. Page 01.pdf. Okay, let's look at another example. Got z is equal to the cube root of x squared plus y at 3, -1, 2. Now, our steps say that we want to find partial with respect to x, y, and z. Well, we need to get everything over one side, so I'm going to take this cube root over to the left side. Doesn't matter which side you take it to. Though you will take it to one side, and it may be your vector we're finding, the unit normal vector, may be pointing inward or outward. But that's no big deal, because we're just looking for a direction, really. And Let me go ahead and rewrite that. We know we don't want radicals, so this will be x squared plus y to the 1/3 power equals 0. Okay, have to have a 0 on one side, and then this is going to be our f. So first thing we need to do is find del f x, y, z is going to equal partial respect to x, I, plus the partial respect to y, j, plus the partial respect to z, k. Well, the derivative respect to x. The z drops away, that's just considered like a constant, minus, take your power, put it out in front, so we got minus 1/3 x squared plus y, lower your power by 1, 1/3 minus 1 is negative 2/3, and then times the derivative of what's inside the parentheses. And we're taking the partial respect to x, so this will be 2x. The y drops away because we treat it as a constant. I. Now partial respect to y. Well, the z drops away again. We have the negative here. Take the power, put it out in front. So we got negative 1/3 x squared plus y to the negative 2/3 times the derivative of what's inside the parentheses with respect to y, which would be 1. That's j. And then plus the partial respect to z. This radical doesn't have any z's in it, so that drops away. And derivative of z is 1. So this is 1 times k. This is step 1. Which is going to give us negative 1 over 3 times x squared plus y to the 2/3. Actually, I guess I need 2x up on top, don't I? Okay. There we go. 3's down there, negative 0, and 2x is up the top, I. The minus goes out in front, and so this is 3, and then x squared plus y to the 2/3, j, and then there's just a 1 up here. And then plus k. Well, that's step 1. Step 2 is we want to plug in our point. So that's what this says, plug in your point. So del f of, what is our point? 3, negative 1, 2. So 3, negative 1, 2. So we're going to have negative 2 times 3. This is our x, this is our y, and this is our z. Over 3 times x squared, so we'll have 3 squared plus, minus 1, that's at the y, 2/3, minus 1 over 3, and then 3 squared minus 1 to the 2/3, j, that's I. Well, this headphones are really bothering my ears, plus k. Well, the denominators here. We got 3 squared minus 1. So 3 squared is 9, minus 1 is 8. So we got negative 6 over 3 times 8 to the 2/3. Minus, or I, minus 1 over 3 times 8 to the 2/3, j, plus k. 8 to the 2/3. You remember this from intermediate algebra, when you have a number to a fractional power, you got a property says you can take the number up on top, the numerator, put it on the outside of the parentheses. So we can rewrite this as 8 to the 1/3 to the second power. And the 8 to the 1/3 is the cube root of 8. And cube root of 8, we're looking for something times itself 3 times, which works out well because 8 is 2 times 2 times 2. So that gives us 2 squared, or gives us 4. So we're going to have negative 6 over 3 times 4, I, minus 1 over 3 times 4, j, plus k. Which gives us 3 times 4 is 12, so this is negative 1/2, I, minus 1/12 j plus k after we plug in our point. Well, now we want to find our magnitude of that. So we'll have square root of negative 1/2 squared plus negative 1/12 squared plus 1 squared. Which gives us 1/4 plus 1 over 144 plus 1. And I guess I want all of them to have the same denominator. That's probably the easiest way. So here I multiplied the bottom part by 36. So I multiplied the top part by 36. Plus 1 over 144 plus 144 over 144. Merge those together. Got a calculator here. Okay. Plus 1 plus 144. 181. So that gives us 181 over 144. Ooh, I'm about out of space here. That's not good. How come I don't have any room? Well, I guess it just took a little bit. Okay. Which gives us square root of 181 over square root of 144, which gives us square root of 181 over 12. Okay, well 4. We need to find our normal vector, which is going to be del f over the magnitude of del f. Well, del f was negative 1/2 I minus 1/12 j plus k over the magnitude, which is square root of 181 over 12. And well, we got a single fraction downstairs, so we'll flip it and multiply it times our top part. So that's going to give us negative 12 over 2 square root of 181. Yeah. I minus 12 over 12 square root of 181 j. Hopefully I don't screw this up. Plus 12 over square root of 181 k. 12 and 2 both divisible by 2, so that gives me negative 6. I'll multiply top and bottom by square root of 181. And we get this. 12's cancel here, and multiply top and bottom by square root of 181. So we got minus square root of 181 over 181 j. And multiply top and bottom by square root of 181 here. And we get 12 square root of 181 over 181 k. I kind of did a few of those steps in my head, so hopefully no basic math errors. But if nothing else, you get the basic idea, which is the important part. Now I could actually graph these and on our program and verify that, because you can tell if it's the unit normal vector. So let me save it. And let me grab a drink and we'll look at the next item. Okay. Now this is finding the equation of the tangent plane to the surface at the given point. X naught, Y naught, Z naught. Well, first thing we're going to do is find our partials, vector X, Y, and Z. Then plug in our point into those partials. And then the equation of the plane is going to be given by this formula. So these are pretty basic problems. Let's look at one. F of xy is equal to x squared minus 3y plus y squared at 317. Okay. So first step, find our partials. Now, you won't necessarily have all of these in this one. Yeah, actually, what? Never mind. No, I'm thinking, because what do we have here? We have z, right? So we got z is equal to x squared minus 3y plus y squared. If I take those over to the left side, we're going to have z minus x squared plus 3y minus y squared equal to 0. And this will be our f. And, of course, we have to have a 0 here. Minus 3, or take that over, take that over, take that over. Okay. So then, want to find the partials. It's back to x. Well, the z's and y's drop away, so we got negative 2x. And partials back to y. Those drop away, and we got 3 minus 2y. And the partials back to z. Which those drop away, and we just got 1. Like that. Then we want to plug in our point. Remember, this is your x, this is your y, and this is your z. So put 3 in for the x. So that gives us negative 2 times 3, which gives us negative 6. And we'll plug 1 in for the y. So we got 3 minus 2 times 1, which gives us 1. And then the partials back to z is just 1, because there is nothing. Then our equation of the plane is going to be given by this formula. So we've got partials respect to x times x minus x naught plus partials back to y times y minus y naught plus the partials respect to z times z minus z naught equal to 0. Well, this up here is our initial point. So this is our x naught, y naught, and z naught. And partials back to x after we plugged in our point was negative 6. So I have negative 6 there, and then x minus 3. That 3 comes from the x naught up here. Plus partials back to y, which is 1, times y minus 1. Plus 1 here, and then z minus 7 equal to 0. And let's multiply this through. Negative 6 times x. What if they leave it in this form? But negative 6x plus 18 plus y minus 1 plus z minus 7 equal to 0. So I'm going to have negative 6x plus y plus z. 18 minus 1 is 17, minus 7 is 10. So that'd be our equation of the tangent plane. Assuming I multiplied everything correctly. Looks correct. All the numbers and everything. Okay. Let's take a look at this one. I think I got room. Got f of xy is equal to e to the 3x minus 2y and 2, 3, 1. Let's actually look at this one. I'm just curious. So if I come over to one plot, before we do the next one, we'll do window, 3 dimensions, and we're going to plug that in, so that's explicit. So I do equation explicit, and it says x squared. So I do x caret 2 plus minus 3y plus y caret 2. And it's going to be at 0.317, so let me change this to negative 8, 8, negative 8, 8, and click OK. Well, this isn't going to be as nice as I thought. Might not be able to see it, but we'll see. We'll try. And then I want to graph this right here. First off, let's do the 0.317. So 317. The equation, choose point, Cartesian, and 317. And I'll make it solid. I'll do a 4. And click OK. And of course, it doesn't go down that far. Yeah, that's not going to work well. Let me try one other package. TI Inspire, assuming my trial version hasn't run out. I haven't bought this package yet. Still not quite convinced I want to. I seem to be having better luck with my free program, WinPlot. 9 days left. I guess I've got to decide here pretty soon. Continue with my trial. The WinPlot isn't perfect either. Okay. And I'll do a graph. And menu, and choose View, 3D Graphing. And we're going to be graphing x squared minus 3y plus y squared. Okay, so that's what our graph looks like. And then I want to menu. Actually, I don't want to do that. I do escape, and do a tab. There we go. And I want to plug in this other one, but I will need to solve it for z. So I'll take those over, and I get 6x minus y minus 10. So 6x minus y minus 10. 6x minus y minus 10. And enter. I don't know how to plot a point on here. That's bad. But you can see, assuming I could actually figure out where my point's at. My point was 317, so x is 3, y is 1, and x is 3, y is 1, and then z is 7. What it's doing is it's touching at one point up there. Can't see it, but take my word for it. That's what's happening. Okay, let's look at this one. Let's go back to our steps. So find the equation of the tangent line to the surface at a given point. We want to find our partials, spec x, y, and z. Need to have everything over one side. Remember this notation is the same as having a z here. Is equal to e to the 3x minus 2y, so I'll bring that over. Then we'll get z minus e to the 3x minus 2y equal to 0. Okay, first step, find our partials back to x. Well, the z drops away because we treat it as a constant. The derivative of this negative stays there. Derivative of e to the power is e to the power. That never changes. But you have to multiply it times the derivative of the exponent. And with respect to x, this would be 3. So that's going to give us negative 3e to the 3x minus 2y. Partials back to y. Well, again, that z drops away, and this is still negative e to the 3x minus 2y, times derivative of the exponent, which in terms of y's will be a negative 2. So that gives us 2e to the 3x minus 2y. Then our partials back to z would equal 1, because that doesn't have any z's in it, so it drops away. And derivative of z is 1. Then we need to plug in our point. So partials back to x. Now this is our x naught, y naught, and z naught. So put 2 in for the x. So we got negative 3e 3 times 2 minus 2 times 3. 3 times 2 is 6, minus 2 times 3 is 6. 6 minus 6 is 0. E to the 0 is 1. So this gives us negative 3. Partials back to y will be the 2e to the 3 times 2 minus 2 times 3, which is going to give us 2. And then our partials back to z, once we plug in a point, is 1. Okay, so then we got our partials back to x times x minus x naught, plus our partials back to y times y minus y naught, plus our partials back to z times z minus our z naught, equal to 0. That's just our formula right here. Partials back to x was negative 3 times x minus x naught, which is 2. And then f partials back to y was 2 times y minus y naught, which is 3, plus 1 times z minus z naught, which was 1, equals 0. And I'm just getting those x naught and y naught and z naught from our original point. Well, let's multiply this through. Negative 3 times x is negative 3x. Negative 3 times negative 2 is 6. 2 times y is 2y. 2 times negative 3 is negative 6. And then plus z minus 1 equal to 0. So we're going to have negative 3x plus 2y plus z. 6 minus 6 drops away, so we got minus 1 equals 0. And that's our equation of the plane. Let me save that. I'll take my glasses off. Ow! There. That won't, I don't think it hurt as bad with the headphones on. 4y equals 2 times x plus 5z, 183. Same instructions. Find equation tangent plane to the surface at the given point. So come up here, our first step. Well, we need to get everything over one side first, but let's multiply the 2 through. 2 times x is 2x, 2 times 5z is 10z. And I get everything over on one side. It doesn't matter which side. It works out either way. There we go. So have to have a 0 here, and this will be our f then. First step. Want to find our partials with respect to x, y, and z. So partials with respect to x. 4y drops away. This would be a negative 2. Partials with respect to y gives 4. The x and the z are constant, so they drop away. Partials with respect to z, the x and y are constant, so that gives us negative 10. Well, there's nothing to plug in. There's no variables, so these are just the same for step 2, where we plug in our point for x naught, y naught, and z naught. And then step 3 here, we're going to have a partials of respect to x times x minus x naught, plus partials respect to y times y minus y naught, plus the partials respect to z times z minus z naught, equal to 0. This is a negative 2 here. X minus x naught, which is 1, plus 4 times y minus 8, plus, minus 10, and then z minus 3, equal to 0. Negative 2 times x is negative 2x. Negative 2 times negative 1 is a positive 2. 4 times y is 4y. 4 times negative 8 is negative 32. Negative 10 times z is negative 10z. Negative 10 times negative 3 is a positive 30. So we'll have negative 2x plus 4y minus 10z. 2 minus 32 is negative 30, plus 30 cancels, so there's no numbers left at all. That's weird. And this would be your equation of the tangent plane. But now that I think about it, it's not so weird, because think what our initial graph was. It was a plane, wasn't it? And if you think about it, the tangent plane is going to be that plane. So it's the same thing as what we just found. Okay, let me grab a drink here, and then we'll look at this next item. Okay. Now here we're taking it a step further. We're going to do the same 3 steps, but then we'll add a 4th step on to get our symmetric equations. You see down here, it's just plugging in different items you found up above. X minus x naught over the partial respect to x, y minus y naught over the partial respect to y, z minus z naught over the partial respect to z. So let's look at our first problem with this. And I got room. Yeah, I got plenty of room, I think. 6. Got x squared minus 2y squared plus 7z squared is equal to 0 at 1, 2, 1. Well, again, have to have 0 over here. This is going to be our f. So we'll go through our steps. First step is find our partial respect to the x, y, and z. Well, the y and the z are constants, so this becomes 2x. Partial respect to y, the x and z are constants, so those drop away, and that gives us negative 4y. And partial respect to z is going to give us 14z. Then we'll plug in our point. Remember, this is x naught, y naught, z naught. So our partial respect to x is going to equal to 2 times 1, which is 2. Partial respect to y is going to equal to negative 4 times y, which is 2, so that's negative 8. And partial respect to z is going to equal to 14 times z, which is 1, which gives us 14. Now equation of tangent plane. We're going to have partials partial of f with respect to x times x minus x naught plus partial respect to y times y minus y naught plus partial respect to z times z minus z naught equals 0. This is 2, then x minus 1 or minus 8, and then y minus 2, and then plus 14 and z minus 1 equal to 0. So that gives us 2x minus 2 minus 8y plus 16 plus 14z minus 14 equal to 0. Actually, up here I could have divided everything by 2, couldn't I have? So that would have become a negative x plus 2y minus 5z is equal to 0 in a little bit more simplified form. Okay, so we got 2x minus 8y. I was thinking down in this problem when I saw everything came out as even. 2x minus 8y plus 14z. Negative 2 plus 16 is 14, minus 14 drops away. And we can divide everything by 2, so we got x minus 4y plus 7z is equal to 0. Okay. Now the symmetric equations. We're going to have x minus x naught. So we'll have x minus x naught over the partial with respect to x is equal to y minus y naught, and the partial with respect to y equals z minus z naught over the partial with respect to z. Okay. So x naught was, we'll have x minus 1 over 2 equals y minus 2 over negative 8 equals z minus 1 over 14. And those are our symmetric equations. Okay, let me save that. And let's look at one more of those. Okay, so we got z is equal to e to the xy squared power 0, 2, 0. Well, I need everything over one side, so I'll take that e over. So it becomes a negative e to the xy squared power equals 0. And this will be our f. And of course you have to have a 0 here. First step. We need to find a partial with respect to x, y, and z. Well, the z drops away because I'm taking partials with respect to x, and this becomes a negative e x y squared times the derivative of the exponent with respect to x. Well, the y squared is a constant, so it stays. The derivative of x is 1, so this will just be a y squared. Which gives us negative y squared e to the x y squared. Partial with respect to y. Well, same thing. This is negative e to the x y squared power times the derivative of the exponent with respect to y. The x stays because it's a constant, and derivative of y squared is 2y, so that's 2xy. So that gives us negative 2xy e to the x y squared. And partial with respect to z is equal to 1. Because this doesn't have any z, so it drops away completely. Well, plug in our point. This is, remember, our x naught, y naught, and z naught. So partial with respect to x is going to equal to negative y, which was 2, so negative 2 squared, e to the 0 times 2 squared. Well, 2 squared is 4, times 0 is 0. E to the 0 is 1. So that gives us negative 4. Partial with respect to y. We're going to have negative 2 times x, which is 0, times y, which is 2, times e to some kind of power. Doesn't really matter. I'll write it down, though. Because this 0 right here means this is automatically going to be a 0. And then this is going to be 1. Okay. So we'll have the partials with respect to x times x minus x naught plus partial with respect to y times y minus y naught plus the partials of z with respect to z times z minus z naught equals 0. So this is going to be negative 4, and then x minus 0 plus 0 times y minus 2 plus 1 times z minus 0. So that gives us negative 4x. This drops away. Plus z is equal to 0. Well then, for symmetric equations, we're going to have x minus x naught over partial with respect to x. And since this one's 0, then we won't put that in there. Equals, then z minus z naught over partial with respect to z. So we're going to have x minus 0 over negative 4 equals z minus 0 over 1, which gives us negative 1/4 x equal to z for our symmetric equations. And let me save. Well, do I have room? I might have room. Nah, I'll save it. Now, last thing in this section we're finding is find the angle of inclination theta of the tangent plane to the surface at a given point. Okay, so let's look at this. X squared plus y squared minus 5z is equal to 0. Now you might look at this and think, well, how in the world can they come up with that? Because you know it's coming in from different sides, coming up that point. They're coming up with different inclinations. But realize we're looking at just this point. It's kind of like the idea of when we found the slope of the tangent line at that particular point. We didn't care what was all around it. It's what was happening exactly at that point, and that's what this is finding. Okay. And let's go to our steps. Now, first step is to find del f. So del f is going to equal to the partial with respect to x, I, plus partial with respect to y, j, plus partial with respect to z, k. Well, take the partial with respect to x. The y and z are just constants, so they drop away. So this gives us 2xi. Partial with respect to y. The x and z are constants, so they drop away, and that gives us 2yj. And partial with respect to z gives us minus 5k. Step 2, we want to plug our point in. So we'll plug in 3, 1, 2. So we're going to have 2, this is x, this is y, and this is z. So we'll have 2 times 3, I, plus 2 times 1, j. And there is nothing here, so, okay. So that gives us 6i plus 2j minus 5k. Then we want to find the magnitude. So that's going to equal the square root of 6 squared plus 2 squared plus negative 5 squared, which is 36 plus 4 plus 25. 36 plus 4 is 40, square root of 65. Step 4. Now we want to find the angle. And the angle, I'll modify that formula a little bit, because we can take inverse cosine of both sides, or arc cosine, if you prefer that, is equal to the absolute value of del f of 3, 1, 2, well, the dot product. The absolute value of the dot product of del f and k over the magnitude of del f. Okay. So we got the absolute value, and del f 312 is equal to 6i. So I'm going to have 6i plus 2j minus 5k, dot product of k. Absolute value around those. And this one we already found. That was in step 3. That's square root of 65. Okay. Well, up on top, the dot product, since I don't have any I or j in my second parentheses here, all we have to do is multiply together what's in front of our k. So negative 5 times 1. So we're going to have the absolute value of negative 5 times 1 over the square root of 65. Which negative 5 times 1 is negative 5. Absolute value of that is 5. So we'll have 5 over square root of 65. Now, there's no use to really doing kind of simplifying on that because we're immediately going to plug it in our calculator anyway. And take that one down and bring that one down. Get too much running and I'll have some system error problems or something. I'm going to make sure I'm in degrees because I want to represent it in degrees. I think that's what the particular textbook did. Memory serves me right. And so I'll press mode. I'm in radians, so I want to down arrow to that line, right arrow, press enter in degrees, and then do a second mode exit out. Okay, so we want inverse cosine, so I'll do second cosine 5 divided by second x squared for the square root, and then 65, and then press enter. And we get 51.67 degrees. So that's our angle of inclination. Let's save that. There we go. I think that was the last problem. Yeah, it was. So let me stop the recorders.